Mom and Austin. Am I audible?
Yes, sir.
Okay, just wait a minute. So, does anyone have any doubt from the previous class?
No, sir.
Okay, just wait. I'm going to write the rules for writing nomenclature. You will write with me, okay? So these are the rule. Two rule I have written. Write it with me. Let me know when you are done with the 3 point, or if you have written the fourth, don't erase this. How many rules you have written, both of you? Till what?
Till
There are two more rules. Let me know when you are done up to fifth rule. Then I will explain after writing. Are you done with this, Hamam?
1 minute.
Okay.
Done, sir.
The two more rules are there, which is very easy to understand. The sixth one is oxidation. After writing all this, oxidation, state or oxidation number we can write. Oxidation state of central atom or central metal atom or ion is indicated in Roman numeral. In parenthesis, bracket after the name of central metal atom or ion. We'll explain all this point, very easy it is. When complex is anion or when anionic complex is when complex is anion or we can say coordination sphere has negative charge, then name of central metal atom, CMA, that means central metal atom, ends with 8. Otherwise, no change. The name of central metal atom will be as it is. So first you are going to write it. Then let me Are you done with this? Austin, Humam.
Yes, sir.
Okay. So now I'm going to explain some rule number one. So always remember in inorganic chemistry, like if you have any compound, inorganic compound like NaCl or KCl or anything, you can see this is your positive part. The first one is positive, the second one is negative. And when you are going to write the name, we always write the name of cation first, sodium chloride, and anion at last. Are you getting my point? So basically, in the same way, for this, since complex compound is also inorganic compound, so we always write the name of the positive first. That means if you have any complex compound, you know, the positive lies outside the bracket, which is counter ion, positive counter ion or a spectator ion, if you remember, positive counter ion or a spectator ion. Are you getting my point, both of you, Austin and Humam?
Yes.
Yes,
So
sir.
if there is counter ion, positive counter ion, you are just going to name it, and then you will jump in the square bracket and you will write the name of the ligands in alphabetical order. How will you come to know? You will know, you know each and every name of the ligands. So ligands are named first in alphabetical order, followed by central atom. That means if there is positive counter ion, you are going to name that, then come to the ligands, write the name in alphabetical order, and then you are going to write the name of the central metal atom. Now, if ligand, if prefixes we use bis, tris, tetrakis. Bis means twice, tris means three times, tetrakis means four times, pentakis means five times. This prefixes we use in complex ligand. Okay, like En is there, or EDTA or something like that. Then we use, and for simple ligands we use di-tri-tetra. Like if you have four times amine, so you are going to write tetraamine, pentamine, diamine, like this. So you can see prefixes mono, di, tri, etc. are used to indicate the number of ligands, simple ligands generally we use for this. Now, name of the anionic ligand. These are all about anion basically. I started from anion and you can see ligand. Name of anionic ligands end with O, while cationic ligands end with IUM. For neutral ligand, it is as it is, except for some of the ligands like H2O we call aqua, NH3 we call amine, CO we call carbonyl, NO we call nitrosyl. This name you have to remember. What does this means? Name of the anionic ligand ends with O. Anionic ligand, that means you know Cl minus is anion, you know its name is chloride, but here in IUPAC we will write not chloride, it will be wrong. According to IUPAC, its name end with O, so it becomes chloride. Are you getting my point?
Yes.
OH minus hydroxy it is, but according to IUPAC, its name will be hydroxido or hydroxo. So C2O4, if you remember, C2O4 minus 2, it is an anionic ligand. Its name is oxalate, I told you, but since you are going to write the name, its name becomes oxalato. Are you getting my point?
Yes.
Yes.
So I'm going to write the list of this anionic ligand, cationic ligand, and neutral ligand. Before that, up to this we are done. Now, after the writing the name of the first writing the positive part, then name of the ligand in alphabetical order, and ligand, you know, if it is complex and more than one, you are going to use base trace. If it is simple, then you are going to use di, tri, tetra, and if it is anionic, then you are going to name ends with O, cationic IUM, and as it is. Now, central metal, after name of the central metal atom, you are going to calculate the oxidation state with the help of the formula that is given and put it in Roman numeral in parenthesis just after the name of the central metal atom, and then this is a very important point. If the complex is negative, anionic complex it is, then the name of the central metal atom ends with 8. Now, how will you look at the negativity or complex anion? So very simple. Either it will be directly given, like FeCN whole 6 raised to the power minus 2. It will be directly given, or either if any positive counter ion is there, that means it is anionic complex. Are you getting my point? If
Yes.
any complex positive counter ion is there, that means it combined to neutralize this complex, and since positive is neutralizing, that means there is must be negative charge. So this is your anionic complex. So either it will the negative you can directly see, or either there will be positive counter ion. Are you getting my point, all of you?
Yes.
Yes.
Humam?
Yes.
Okay, now see, I'm going to give you some like anionic ligand. We talked about anionic ligand. Anionic ligand. Now, anionic ligand, you can see Cn minus. Cyanide it is. We call it cyano or cyanido. We can call it cyano or cyanido. Okay. Nc minus. Now it is isocyano or isocyanide, you can call it. Are you getting my point? And name isocyanide it is, but since it is anionic ligand, so name ends with O. F minus, fluoride is this, but the name in this will be ending with O, fluoride. Okay. OH minus, that is hydroxide, so it names hydroxo or hydroxido, you can call it. This is very important. And 3 minus. Azide it is, azido we call it. And minus 3, that is basically nitride, but we call it nitrido. Name ends with O. Are you getting my point?
Yes.
ONO minus, so its name end with nitrito, O, because this representation, that means it is an ambidentate ligand, O donated. NO2 minus, so name will be as it is, nitrito, but here donation is from N, so we are going to write N. Cationic ligands are very rare to use. Now you can see NH2, NH3 positive, hydronium. Just wait a minute, just erase this part. Wait a minute. A little bit I'm confused about this. I'll just write the first. NO plus nitrosonium. Nitroso, its name is nitroson, but it becomes nitrosonium. Nitroson. NO2 plus nitronium. Hydrazinium, not hydronium. NH2, NH3 positive. Hydra gene, that is hydrazinium. It becomes. So very easy it is, right?
So what is N3 minus?
Azido. Azide it is.
Yes.
Got it.
Yes.
It becomes azido. Or let me know when you are done with this. In negative or anionic ligand, write one more. And that is your, I think, SCN minus or NCS. Thiocyaneto. Thiocyaneto S. And if it is NCS minus, then it is cyaneto of just wait. Thiocyaneto S. And if it is NCS minus, then it is thiocyaneto. Got it?
Yes.
Let me know when you are done.
Done, sir.
Very good. Now, first I'm going to explain some of the examples. So let's take example of the first one. PT NH3 hold twice Cl NO2 this. Now, if you want to write the name of the example, this, first look at this. Is there any positive part? No. So directly jump to the ligand. Its name is amine, chloro, and nitro. Now, you are going to write it in alphabetical order. So since two amine is there, so diamine. This is chlorine, which is negatively anionic ligand. So its name will be chlorido. This is NO2 minus. That's why its name will be nitrito. Nitrito. And it's very important to recognize this. This is a what we say. This is a ambidentate ligand. So nitrito N. If it is written like this, that means ambidentate ligand means what? Two donor site, but it can use only one at a time. And if it is written like NO2, that means donor site is N. So you have to determine nitrito N and then come to the platinum. Before writing the platinum, look at this charge. There is zero charge or there is no. That means it is a neutral complex. So its name will be platinum. and then you are going to calculate the oxidation state. It will be 2. Is that clear, both of you?
Yes.
Yes or no? Now, in the same way, I'm going to take another example for the B1. You can see this is your K3, and then chromium is there, then C2O4 is there, whole thrice. Now you are going to look at this. Oh my God, there is a positive counter ion. Positive counter ion, you are going to write it first. And also, if positive counter ion is there, that means this complex is your anionic complex. Humam, are you understanding this concept?
Yes, sir.
So you are just not going to write K3, K4, K5, K2, anything written. You just need to write potassium. Don't use this for this counter ion. You are not going to use di, tri, tetra or anything. Potassium you are going to write, and then a space, left a space some, and then you are going to write the name of the this ligand. So you can see this is your tri, since thrice, oxalato, not oxalate, because oxalate is a negative ligand, and whenever negative ligand comes, its name end with O, so it becomes oxalato. And then chromium, you cannot write chromium because it is anionic ligand, and anionic ligand's name end with 8, so it will be chromate, it becomes chromate. Then you are going to calculate the oxidation state, you will get 3. So this is the name of this complex. Please do write it and do others. Let me know if you have any doubt in this. Might be you will face some problem in this E1. And apart from this, everything I have given already. Also, you should consider, I'm going to give some hints. En is complex ligand. So it is twice. So you are going to use bis and write in bracket bis. What is the name of En, if you remember, Austin and Homamuddin?
Ethylene diamine.
Now, your voice is like there is bass a lot in your voice.
Ethylene diamine.
Yeah, ethane 1, 2 diamine. Or let me know when you are done with this. Lots of questions we need to do practice. Yes, Humam, it is correct. Very good. Dichlorido, bis, ethane 1, 2 diamine, cobalt 3. And at the end, you can see cobalt 3. You have written it correctly. I'm going to show you again. Dichlorido, that is good. Then base, ethane 1, 2 diamine, ethane 1, 2 diamine. And after this, there is chlorine outside the bracket. So you are just going to leave some space and then write chloride, like the way we wrote it for potassium, right? There must be a space between this uh, coordination entity and coordination entity and counter ion. Got it? You forgot this chlorine. So it will be some space, then chloride. Whether chlorine is 1, 2, 3, it doesn't matter. Chloride, you just need to write.
Okay.
Okay, please do the rest one. Let me know when you are done with this. Mom, this is CO3. You know, CO3 is CO3 minus 2. Carbonate its original name, but this is an anionic ligand, so it will be carbonato. Okay.
Okay.
Pentaamine carbonato cobalt 3 chloride. Okay.
Okay.
Okay. One thing I'm going to tell you is that Hg here exists in +1 oxidation state. I already told you. Right now, write it. Any answer for the last one? Yes or no? So see what I'm going to do. This Hg is your mercury. So I'm going to write mercury. And since it is a D block element, so you need to show it in Roman numeral because what do we say? D block element have variable oxidation state only because of that. Now, this is your ligand, which is 4 times. So I can write tetra thiocyanato S. Yes or no? Can I write tetra thiocyanato S? And then comes your cobaltate, not cobalt only, cobaltate, because there is positive counter ion. That means this is an anionic ligand. This is an anionic ligand, cobaltate, and then write down the oxidation state. This is metal, so +1, and this is -1, so -4 becomes -3. When goes on the right hand side, it becomes positive, so +3 it will be. Is that clear, Austin Homamuddin?
Yes.
So why tetrathio? I didn't get.
What did you say?
Why tetrathio?
Tetra, because four is there, na? 4 times.
Okay, and theo?
Tetra thiocyanato. I told you the name of the anionic ligand. Here I wrote it. At the end, I added 2 more in this. SCN minus thiocyanato S. Its name is thiocyanato. NCS minus thiocyanato N.
Okay.
Okay. So can I change the slide?
Yes.
Okay. Now I'm going to give you one more question about this, which is very easy. Let me know. You just need to write the name of this all compound. Oh, mom. How many ligands present in the first one? How many types of ligand?
Sorry, sir.
How many types of ligand present in A complex?
4.
4 types. This is your central metal atom, right? This is your first type of ligand. This is another type of ligand. This is another type of ligand, right? 3 type of ligand is there. So what will be the name? There is no positive counter ion, so directly jumping into the complex compound. So the name will be, see what you have missed, tetraamine aqua, and then there is a chlorido that you forgot to write, chlorido. Then comes your central metal atom, and anion is not complex, anionic, or sorry, complex is not anionic complex, and neither it is positive, so it will be cobalt. Then calculating oxidation state, this is 0, this is 0, this is -1, this is -1 into 2, so it becomes 3. And at last there is negative counter ion, so you just need to write chloride. So you forgot to write the chloride, this chloride as a ligand. Are you getting my point? Yes or no?
Yes, sir.
Please do write it. For some metal, Latin name is used, like we don't use iron, we use ferrate. So I'll give you the list of that as well, but first write it correctly. B is potassium, very good. Then some space, tetrahydrogen. Hydro you only wrote. OH minus is hydroxido, or you can write hydroxo. Are you getting my point? Not hydro only. Hydro means water.
Okay, okay.
OH is hydroxide, right? Hydroxide. So what you can do, simple, OH is hydroxide. You can remove E and add O at the place. Hydroxido or hydroxo you can use. So the rest part is correct up to this. Potassium tetrahydroxido, zincate, that is also good too. Very good. Please do the rest. Austin, are you able to solve this? Yes or no? No response from you.
Yes, sir. Yes.
Okay. Potassium trioxalato, and since it is an ionic ligand, so aluminate. Aluminate 3. Very good. Austin, you are already done with all this.
Yes.
Okay. Not dichloro. Dichlorido you are going to write now. This is a negative ligand, anionic ligand. So dichlorido base ethane 1, 2 diamine and cobalt 3. That's correct. Its name is carbonyl. Mom, this is basically tetracarbonyl. Carbonyl. Nickel 0. Got it. Austin, you
Yes,
are
sir.
also done with all of this.
Yes, sir.
Okay, let me know both of you. Have you done this question before? Okay, one most important thing that I needed to discuss in your exam at Learnivio, you have in syllabus alcohol and aldehydes, right?
Yes.
So I was thinking since your exam is there, I should start alcohol and stop this chapter at this point from the next class. From the next class, I should start alcohol because this is already completed in your exam school as well. Because this chapter will also take some time. Are you getting my point,
Not
Austin
completed
and all?
in my school.
Alcohol not completed in your school.
No, we didn't start this.
And what about aldehyde?
No, sir.
Now, Austin, alcohol completed in your school, right?
Yes, sir.
We'll think about this. Please do this question. Specify the oxygen. Have you done this question before? This is question for oxidation number. Is it aqua cyanato base ethane 1, 2 diamine or ethylene diamine? Cobalt 3, that is also good. One is 3, 2 is also 3. Okay, 2 is also 3. No. Second is 3, that's good. Third is 2. Fourth is 3. And the fifth one is 3. Very good. Oh, very good, both of you. Just wait a minute, please. NiCl4 raised to the power -2. NiCN whole 4 raised to the power -2. Write the name of all this. Are you done with this? To improve in this, not chloride. It will not be chloride. Tetrachloride. Nickelate 2. Yes or no? Austin, this is the right or wrong?
Yes.
Very good. For this, it will be tetra, cyano or cyanato, cyano, nickelate 2 again. So this chapter you have already studied in a school, right? Both of you.
Yes.
Okay.
After
So after this, we have the next topic, that is your isomerism. After isomerism, we are going to do VBT, which is very important. And after this, we are going to do CFT. And then we will do Warner's theory. Are you getting my point?
Yes.
Already, I think you have completed this chapter in your school, right?
Yes.
So let's write the definition of what do we say? Isomerism. Compounds having same molecular formula but different arrangements of atom due to which they differ in one or more physical properties. Are called isomers, and the phenomenon is called isomerism. So very simple it is. Same molecular formula but different arrangement of atoms due to which they have different properties. They differ in one or more physical properties are called isomers, and this phenomena is known as isomerism. Please do write it, then let me know.